This is a question for the lab. How can we do this operation? As you see, we have some routines here. We should write the comment which is needed for this question. Okay, how can we uh, poll port 2.0? Maybe we can use some conditional branching command. For example, we have to use in here bit-based command. To do this, we can use jump bit command. Jump if bit port 2.0 is 1, go to the address may be start, because when this condition satisfied, your program will go to the start label again. For any pin or any port, uh, first of all, the value of the pin is logic 1. But if you push any button connected to this related pin, uh, this value will be 0. Again, when you release the related pin, uh, pin value will be again logic 1. Okay, this is the key for our question now. When you pushed this command, so we can say about this line, button connected to port 2.0 is polled according to the push. So we can say if you push this command, your program will continue to the next line. Okay. So what is the next line for this question? Port 1.0 should be convert. So we can use here CPL. CPL means complement, as you know. Complement port 1.0. And then program will go to the start again. Start label. Maybe we can do this operation by using these commands. We can compile this program, but in here we have some warning or error, as you see. The related error, if you click 2 times on the error, you can see the related line. In here we have a error, and then also in this line we have another error. So if you use port, you have to add your header file according to your microprocessor or microcontroller. When you click right side of your mouse, you can see insert include regx 51.hex. This is header file for our microcontroller. And then if you compile again, you can see we don't have any error and any warning. We can check our program by using the debug session. We need some peripheral units for this operation, which are port 2 and port 1. You can get the related peripheral units by using this icon and IO ports, port 1 and also port 2. As I said before, the first value of the ports will be FFX. Its mean all pins of this port will be 1. Okay, as you see. And program start with this line, 6th line, as jump start. Let's continue from step by step. In this step, our code go start label, because port 2.0 is 1. When your pin is logic 1, your program will stay here. But if you press pin, as you see, your program will go to the next line because this condition is not satisfied yet. And as you see, your program will go to the next line. And in this line, CPL port 1.0, we can see the value of the port 1.0 here. Here we have one value. So when you complement of this value, it will be 0. Yes. And then your program will go to the start label again. And if your pin is 1 again, your program will stay here as you see. How can we check our code by using the Proteus now? 8051 based microcontroller. We need some requirements here. We need a power, a reset circuit, crystal and tube capacitor, and also external access pin. So we have to do it. But first of all, we select our microcontroller by using this icon. You can get your microcontroller. As you know, our microcontroller 1851 based, so you can write 1851 as keywords. And in this part, we need microcontroller. In this library, we have many microcontroller, but we can use Atmel microcontroller because, as you know, our microcontroller Atmel based. In here, you cannot see our microcontroller, but you can select one of them. For example, 8089C51. This is 1851 based microcontroller. It has 4 kilobytes code memory, 33 megahertz crystal, and 2 timer and counter and UART. Maybe we can use it. And now we have microcontroller. Another requirement should be satisfied according to this figure. So first of all, we have to do it. And again, P, we need a crystal. Yes, crystal here. Okay. And also 2 capacitor, which value we can learn here. 10 microfarads. We need 100 ohm and 8.2 kilo. So we can get the library 10 microfarads. Yes, in here you can see many capacitor options. Maybe you can change the value of the capacitance. Yes, resistor 100 ohm. Yes, in here many types you can see. And also we need 8.2 kilo ohm. In here we have many options again. We can use one of them. And then also we need ground, as you know. Can get ground as here. And then we can connect this component to each other. Yes, this is about the crystal. Yes. What about the crystal capacitor? 30 picofarad. We should get it. Yes. And also we need reset input. To do this, we need also button. In here you can see we need a button. Yes. Our reset should be connected to this point. And then we need also power, and should set plus 5 volt. It's just finished. And then continue. Yes, as you hear, we need a ground to the 20 number pin and also power to the 40 number pin. But in here, our microcontroller don't have ground and power pin, as you see. What is the problem? Maybe we can understand if you click 2 times on the microcontroller and you can check the hidden pins, and you can see in here this pin, these pins are hidden. Okay, not important for us. What is the other connection? In here we need also power because we will use internal program memory. Okay, so to do this we need also another power to the external access pin here, and then we should set this value plus 5 volt. It's finished. Another connection is about the our uh, question, and in our question we need uh, a button on port 2.0, as you see. What about the others? And we need a connection on the port 1.0. Maybe we can connect a LED on this pin and we can see easily. So to do this, we need also LED. Yes, LED, but we want to see. So to do this, you can select active LED options. Okay, port 1.0. Here, maybe we should connect. Sorry, we should connect a resistor to protect our LEDs, and then we should also use a ground here. For this question, we have all of the components here. Now we can check our program on this model. Okay, but how can we do it? First of all, we have to load machine codes to this microcontroller, because as you know, if you compile any program, in here you can see a hex file is established anywhere. It's about the project file. For our computer, I can select one as like that. In here, program file, I can select on C driver and Keil and object, because I know this all machine codes on this file. In here, micro 1 hex. What is the micro 1? As you see, my project file name is micro 1. So it should be for me, and then okay. Yes, let's start this model and examine in detail. Yes, start this model. As you see, uh, this LED is turned on at first because we know this. At first, all ports value is logic 1. Okay, after the reset, or at first, all ports has logic 1 value. It means if you connect any LED, you can get some light on it. So to this program, when I press this button, this LED should be turn off. Let's try it. Yes, as you see, LED is turned off. If I click or press one more time, it should be one, or it should be turned off, turn on. In this program, we know this. You should only press the button, not about the released one. Maybe we can do this operation. When you press this button, your LED will not be turned on, but if you pushed and then released, your LED should be convert. Okay, okay. This is the new question for us. Now we should do a modifying on this program. What should we do now? In here we should use JN bit. It means jump if not bit for the released. Jump if not bit for 2.0. We should go to the X. Where is X? X is here. This comment is about the button released or not. This is about it. Maybe we can compile again. You can try on debug session again, step by step. If you click for 2.0, your program will go to the next line. It's mean number 9, this label. Let's try it. Yes, as you see, our program in here now. But if you don't release the related pin or button, your program will stay here. Released now, your program will go to the next line. Let's check on Proteus model. Sorry, we have to stop it before, and we should select again. Yes, let's start. Yes, when you press this button, as you see, your LED is not converted now. But when I released this button, I expect that this LED will be turned off. We can check our program code by using the Proteus as like that. Okay. Maybe we can modify our question again. For example, when port 2.1 is pressed and also port 2.0 is pressed and released, the LED connected to the port 1.0 should be converted. Okay, this is another question. Now, to do this, at first, we should check the port 1.2. So we can use jump if bit port 2.1. Go to the start. But now, in here, we should change the label value in this line, because if you are in this line, it's mean port 2.1 is already pressed. Okay, now we need another label here, x1 for example. Let's compile it, and we don't have an error and warning. Let's go to this program model, but we need another button here. Now we need load the machine codes again. Yes, let's start. First of all, I have to press this button, first of all, and then when I press this button and release this pin, uh, LED will be turned off. Maybe we can try one more time. If you don't press this one, if you don't press this button, okay, when you press this button, this LED will not be changed, as you see. But if I pressed at first to this button, and then if I press this, LED will be turned on again. Maybe we can try another options. Assume that we don't need to release this button, and also we don't need this. If I need only this one, I have to show you one issue on this model. The other option for this question now, for this code, we know this. If you press port 2.0, port 1.0 should be converted, right? This code do this operation. Let's check it. Yes, I have to select my machine codes and then start your program and press this button. As you see on LED is turned on for each time. But it is not true. Uh, Actually, now LED is turned on and off, on off, on off, on off. But we cannot see this. Okay, because when you see your codes again, yes, if you press this button, your program will convert port 1.0 and then sjump start, it means sjump x1. If you press again, complement port 1.0 again. Okay. Uh, all of these operation actually microseconds, need microseconds time. Okay. So all operations are done in many less time. So if you want to see this, maybe you can use some loops to get delay. Okay, how can we do it? First of all, we should write some numbers as like that, maybe 100 decimal, move 20 hex, 100 decimal, and then after the complement operation, your program will stay some time here. Okay, how can we do it? Decrement jump if not 0, 10 hex for example, x2 we can say. Where is x2? x2 should be here. And then if your number is 0, your program will go to the next line. In here we should load the same value on the 10 hex, and then the increment jump if not 0, 20 hex, and x2 again. Now, what is going on here? Maybe it's jump start, okay, x1. Okay, now what is going on here? Yes, we have some initial values here, and checking the button value, and then complement some pin, and then in here we need some times, right? To do this, we write a program dj and z, decrement this value if not equal to the 0, go to the x2 again. X2 means again number 12 line, and then if you 0 here, so your program will go to the next line. The initial value is loaded again, then uh, 20 hex value, we know this, 100 decimal, decrement this value, it means 99, and then go to the x2 again. Do this operation again 10 times. So if you are in this line, actually you did, sorry, 100 times 100 loop. Okay, it means that. Maybe we can check this program now. Yes, when you press this button, your LED will be turned off, uh, and sometime after some time it will be turned on again. I will expect this. Yes, you can see as like that. If you want to do increase this value, this time value, maybe you can use another uh, register to do this. For example, move 21 hex 10 decimal, and the initial value is loaded again. The increment jump if not 0, 21 hex, and go to the x2. Now we will do this operation if you are here times 10. Let's check it. Maybe we can increase now again. It will be 30, 100. As you see, the time delay is so high now. You can see easily. Okay, this is another application for us. Maybe we can write the same delay before the complement operation, but we have to change the label as like that. Now, if I press this button, after the some time, this LED will be turned on.